Good morning, Walter. I decided after watching your two latest videos this morning that I'm going to make a quick video update on my shaper so you can see how things are going. I know I've been sending update photographs, and you have too, as we've gone along here in the recent past, but I realized after watching your video this morning that they don't tell all. So anyway, your video was very interesting this morning, and I was really impressed with the work you're doing and some of the things that you've done to actually improve the construction of the overall unit. And I'm sure you know that your setup is going to be better than mine in reality. Mine is, I've tried to copy the original, and maybe some of those original ideas weren't the best. But anyway, I thought I'd make a quick video this morning, and this will be the last one for a while, just to let you know where I'm at and some of the difficulties I've had, and so forth and so on. So I'm going to what I'm going to do this morning, I don't have a plan. This is just kind of helter-skelter, but I'm just going to show you some of the things I've been doing and talk about the tool bits and the front unit and some places that I've had problems and maybe some of the solutions that I've come up with for myself. So I'm going to turn the viewer around here so I can see what's going on. Let's see here. There we go. So I don't know. Okay, there we go. Yeah, one way the viewer is, if I get it tilted right, it's right side up, so I'm good. Okay. As you know, I had some difficulties with the front unit here. Let me zoom in on that just a little bit. I don't know if I can't go too far. Well, maybe I'll just leave it where it is. The thrust bearing, as you know, threads into the casting here, the cast iron, and so that's held in place. And the bearing in this thrust housing is held in place by two screws. So I had originally made a smaller unit for this, and which I like better. Actually, I think something in between would be appropriate. This is a little bit too large, the dial and the thrust housing, bearing housing, but something in between this size and the size that I originally made, it would probably be best. I think I threw all that stuff in a plastic bag. I don't know if I still have it. Oh, here it is. So, all right. So this is what I originally made, and you can see it's teeny tiny compared to this one. But I think something in between would work probably better. And then this bearing is, there's nothing to hold it in. So what I did was I put some Loctite on it, but I found out, and that probably would work just fine, because the dial, the little piece for the dial, has a shoulder on it, and that actually holds the bearing in place. And so the Loctite only keeps the bearing housing from spinning in the housing itself. So anyway, but what I found out was the main problem was the dial piece being held in place. So that's this piece here. And what I did was, what happens is there's so much force up from the cutting action that even though I I milled a beveled flat on the lead screw for the set screw in the dial, which should hold. It doesn't, because it only has to move a few thousandths, and then we got a huge amount of play in this front unit. So what I did the other day was, and this is per the original, is I made a double nut to go on there. And let me zoom in on that so you can see. I probably need to move the camera a little bit. Let's see if I move the camera a little bit here. There we go. Now there you can see. So I made this double nut here. And that holds the dial down tight against the housing, and there's a shoulder on the lead screw, so that pulls everything together tightly, and so there's no play anymore, and it seems to work. And then I still have the set screw in the dial unit, so that against a beveled flat on the lead screw, so that all works. Now I was getting frustrated because I never could get this set up to cut right, and the reason is this, even though it wasn't getting pushed up much, the set screw just doesn't hold it. So the other thing I did, and this may not be the final result, I'm not real pleased with the handle I made here, but I did, let me just move that up just a little bit here. See if I can get that in the viewer. So I made a crank for the top here, and actually that worked out pretty good. It's not real fancy, and I really, maybe I need to do it again, but I just made that in the lathe, and what worked out really well for this was the forming tool holder that I built. And that allowed me to make a couple little cutters that cut these radiuses on here, and then I just turned a tapered place right here. And that was actually pretty easy to make a ball crank that way, and I had no problems at all. Actually, I made that very quickly. What I did have a little difficulty is trying to configure the handle here, so but that's okay. You know, this functions and it works, and it's threaded in here, so I can actually change it if I want. But this portion seems to be about right, and the size seems about right. I think if the dial was slightly smaller, that this would all go together quite nicely, and you know, scale wise it would all fit together. So actually, the thing is working now. I've solved a lot of problems, and I've been working with tool bits, which I was working with before, but I wasn't having any good results. But now that I've got this portion nice and solid up here, I'm getting results now, so I'm happy with that. Yesterday I came out. Well, one thing. Let me tell you about one other thing. So I'm using a. Let me zoom out just a little bit here. I realize my mouth gets ahead of what I'm doing here. I'm trying to do this without standing behind it here. So the clapper, when I made it, I realized, you know, it's going to be hard to make a square hole in here. So this is just a round hole. So the next problem was trying to figure out how to grind the tool bits. Well, that was pretty easily solved because I've had that problem before. So what I did was I just made a little holder here with a couple set screws in it, and a hole in the end, which is 5/16, which is the size of the HSS steel that I bought for the tool bits. So this just fits, well, wrong hole, but this just fits in here, and I can tighten down the set screw. That way, you know, I have 4 flat sides to lay on the table of the grinder, so I can accurately grind the tool bits the way I want them, or pretty close. So that solved that problem. So that worked. The next problem was, and I haven't figured out a good way to solve that except by eyeball, but the next problem is when you place the tool bit in the clapper here, because it's not square, you have to get it oriented right. So that's no big deal, actually. I just been kind of doing it by eye, and that seems to work pretty good. But so it would be better. I would much prefer a square hole in here. And I see some shapers, they have a round hole, but most have a square. So that way I can use a regular square tool bit material and HSS tool bit material, and I can, you know, I can more easily grind them without having to use this little fixture, and also I can orient them very easily. So I know I can mark a flat on these and go ahead and grind a flat on here, and that would orient them too. But I right now I'm just doing it by eye, so that works out pretty good. Also, last time I had some troubles. I was a little bit in quandary about what was going on the other side, but I've got the pin. The pin works good. This thing runs in either direction just fine. I just have to move the pin, and then the center pin. All I have to do is flop this up and drive the center pin in there, and that enables me to. It stops this from moving, because the pawl doesn't engage with the star wheel anymore, and that enables me to cut a slot. Slot cutting turned out to be a little bit of a problem, and I still don't have it completely resolved because I haven't taken the time to grind up some little tool bits. Here's one I just was fooling around with, and I think this is just any size. It doesn't. I didn't care, you know, what it was. Actually, I think it's about 90 thousandths, 85 thousandths or something. But anyway, one problem I had right away is the tool bit would dig in, and one problem was the fact that this thing had slop and play in it, so that didn't help. But the next thing was to get this thing to work smoothly, especially in soft materials. I had to eliminate the back rake on the face of the tool bit. So once I did that helped a lot. It doesn't dig in now, but it doesn't work perfectly. But I've only played with it just this one little sample, and so I'm sure that's going to get resolved. This is a piece of aluminum that I don't know if you can see in the camera, but I used a see if where is it? Oh, it's in here. Well, I won't take it out right now, but I ground a shear cutting tool bit that's basically flat on the bottom, I guess, with a slight curve to it, and it just, if you can take off 2 or 3 thousandths, whatever, and it just leaves like a mirror finish on aluminum. You know, it's not, I mean, not perfect, but it's way better than you'd get with even a fly cutter on the mill. So it just gives you like just a beautiful mirror finish. So that's on a piece of aluminum. I also got this in my hand. This is a slot I cut. So that worked out really good. In aluminum, the way that tool bit was ground, I don't have any chatter whatsoever. But yeah, you know, you can't take a huge bite. But you just, this little piece here, I'm just taking short strokes, and in a few minutes, I've got a 1/8 deep slot there with no problem. So let's say making a 1/8 by 1/8 slot to put a key in or something is very simple. You know, works very smoothly, very good. Also, I don't know if I got, here's one surface. I made a tool bit that I call it a roughing tool bit, but it's still very smooth and very nice surface, actually. And I'm taking, the feed is 10 thousandths per pass. So let's see if that tool bit is here someplace. And what I've done, here's that tool bit, you know. Can't see what I'm doing there. Can't see what I'm doing here. The face of it is black. That reminds me of that's the face. But I just colored it black with a marker pen. So that's that, and that leaves a very nice finish, actually. But it's not a mirror finish, but it's still a nice finish. And so, don't think, here's a piece of brass that I did, and I used the shear bit on that, and it's pretty mirror type finish too. Not as quite as shiny as the aluminum, and I tried to cut some slots in there, and that worked quite well on the brass also. So that I was satisfied with that. This was a piece of this was just a piece of cast iron that was laying around here, and it had this type of finish on it from the end mill, is what it had. I just stuck it in the vise and used the shear bit on this. And it's not a mirror finish either, but it's pretty nice. It's when you feel it, it's just smooth as glass. But you can see the tool bit marks in it. But it worked pretty nice. So I'm pretty happy with that. The other thing I'm happy with is that I haven't completely spent a bunch of time checking, but just on these little blocks, I went around and squared up some sides on them, and just to check with a micrometer here and there to see how square my cuts were. And I guess my scraping jobs paid off, because everything is coming out very accurate from one end to the other. So I'm not having any problems there. But these are just small blocks. So on a longer surface, I may be having some problems. I don't know. We'll see. But I know it's not too far out. Everything's pretty close. So if I have to do some additional scraping or shimming or whatever to get it more accurate, but it's pretty accurate right now. It's pretty good. I'm pretty satisfied with the way it's come out. So I don't know what other things I've done here. I'm still trying to figure out what to do about this vise. I think I need a vise that's maybe about a half an inch. This is 2 inches from bottom to top, and this may work for your unit. And a 2-inch vise is easy to come by, right? That's not a problem. But a vise that's let's say a half an inch lower than this is not so easy to come by. I've looked around to see if I can find a vise that would work on here better than this does. The reason I'm not crazy about this height vise is that right now, you know, this dovetail is not fully energized, but it's not far off. But I don't like the idea of having to move this way up and way down, although I think it would work just fine. But I think it's better if most of your cuts are somewhere in the intermediate portion, in other words, if the dovetail is separated by 50% one way or the other, I think that's just fine. So a vise, the appropriate height would be better. That's what I'm thinking. Maybe I'm being too fussy, I don't know. But I'm sure this is 0.8, so that's 80% the size of the original, as far as I can calculate from the photographs and some measurements. But other than that, you know, I don't know exactly, but I'm pretty sure it's pretty close. So, you know, the original vise probably, I'm thinking, was lower than this, but I don't know that, and I don't have one to check, and I don't know anybody that does. So anyway, that's where that's at. And it's, the cutting operation is going really well. I mean, there's no problem with that at all. I've got a piece of 1018 in there right now, and you know, everything I cut with my little roughing tool bit that I ground and the shear tool bit that I ground, they're all working just fine. Take my word for it. So, and also, now that I've got this front unit all tightened up, it's much easier to, you know, set up the height. And actually, once I take the backlash out, I can dial this in to take off a 1/2 thousandths if I want. So that part is working good. This 1018 right here, I just ran the shear bit across that, and it's just like glass. It feels just like glass. So why don't I, before I leave here, I don't want to make this a long video. This is just a short, quick video because just to let you know where I'm at. But maybe I'll take a couple cuts across here, and then take this out of the vise. And I think, I mean, this piece of 1018 is just a long, narrow piece, and I've made different cuts along it with different bits. So some areas are real smooth. The center area is a little higher, so I can work on that pretty easily. Let me see here. This looks like, I don't know where I left off yesterday, but let me move this crank over here, and there we go. So let me, you know, I think that I left this someplace. Let me see. So let's just take off. Oh, I got backlash in here. Okay, hang on a minute. Well, let's see where that turns out to be. Let me this tool bit cuts in the center of the arc that's on the bottom. So it's starting to cut right there. Okay, so let me go back over. Take about 3 thousandths off, I guess. There we go. I don't know if I'm getting that right at the edge or not, but that's about 3 thousandths cut. Let me put a little bit of put a little oil on that. I have some oil here. I'm just, that, you know, I don't know how much that helps. Doesn't make a huge difference. Let me zoom in a little bit on that, and then I'll have to move. Let me move this camera down. Is that it? Let me see. Yeah, well, hopefully you can see. Now this little section in the center here is about, I'm guessing, but it's about 1 inch wide, something like that. And I'm cutting off 3/1000ths. Remember, this is a finished cut, so you're not trying to take off much. I put the roughing bit in here, and I can pretty easily take off about 17/1000ths at a pass. That's a little harder, a little more work, but everything seems to be pretty stable. Well, there we go. Okay, so let me dust this off a little bit. Get rid of the little swarf there. Wait. No, you can see where I started here. It's not perfect, but that looks pretty good actually. I think there might, not sure. I was pretty close to the edge. Oh, got a bunch of swarf in there. Alright, so maybe I got the camera zoomed in too far now, so zoom out a little bit. So this, you can see the surface finish there. It's got some little lines in there. It's not like a mirror, but it feels like a mirror, you know. Even down here where I'd made a similar cut, now you can see down here at this end, these are the roughing cuts down at this end. You can see the difference between the roughing cuts and the smooth cut, you know. These cuts are a lot rougher down here. No. Anyway, that's where that's at. I haven't tried making a slot in the steel yet, but the brass just, you know, is not as far as the slot. The slot had a little chatter, so, but that's just the tool bit grinding, because this is grabby stuff, you know, so you got to be careful. The 6061 aluminum is, you know, it just works beautifully. So I was really pleased with that. But yeah, as you know, most things I'm working with around here are steel, so this has to work, and also the cast iron has to work. So let's see. Let me put this piece of cast iron in here. I don't remember. I think if I remember right, that I just laid a parallel underneath. See if it'll fit in the vise here. Yeah, so it fits in the vise. Well, let's just put that in the vise. We'll make a quick cut on that, just for the heck of it. So we just bring it up. Now let me bring this down. This. No. Maybe take about 1 more thousandth off or something. A little bit. Let me bring it over. There we go. Yeah. Let me take another couple thousandths off. Okay, I didn't get the edge. The edge isn't beautiful. All right. Now let's just do that. Let me see. I got a little oil in this brush. I don't need oil on this. What am I doing here? piece of cast iron actually. You don't need to put any oil on there. Anyway, so the appropriate chips are coming off. This being cast iron, they're little pellets, right? The steel was coming with some long serrated chips. I am encouraged. I was a little disappointed at first, but trying to get all this working and figure out what the problems were. But now I've got it working. I don't seem to be having any problems. I'll tell you about another problem that I had when I get done here. I don't know. I have a bag of stuff around here somewhere. I don't know what I've done with it. Let's see here. Let me, I'm sorry I didn't zoom in earlier. I think all these, I've come to the conclusion that I'm going to have to grind up a bunch of tool bits. Based on the kind of material that I want to cut, because they don't all cut the same way, you know. There are differences like anything else. So I don't think this shear bit, the way it's made, cuts the cast iron quite as nicely as I'd like. Of course, it might help if I take a lesser cut. I don't know how many thousandths I'm removing here. So let's take a look at that. Now, of course, that doesn't look as good as the aluminum does, you know. Let's see. Where I started the cut, of course, is kind of flaky looking because I didn't start off the edge far. That feels very good. Let me. I can't. I have to zoom out again here. So you can see the edge here. It's not so great because that's just where I started the cut. But I didn't adjust the depth of cut till I got over a little bit. But this feels just glass smooth actually. If I hit that on some wet and dry or something, that would probably look beautiful actually. So that I'm real happy with that. It's not perfect, but at this point, you know, I haven't fooled around with it. Only fooled around with it a little bit yesterday after I got things sort of working. And let's see if I can. Oh, here's my stuff. So as you know, here's my first Catastrophe. So this was just a dumb thing to do. I was trying to fool around with the slotting tool bit, and it grabbed the aluminum, I guess, or the steel, whatever I was fooling with, and so the result was it just broke the clapper. Bam! Snapped that sucker right off. So but I think this, I say stupid because it wasn't a very bright thing to do. I don't even know what I was thinking. I was just milling on a bunch of scraps, and I thought, okay, there's a scrap that'll make the clapper. So I roughed it out and ended up making the clapper out of a piece of cast iron. Well, I don't think that was a good idea. I doubt the original was cast iron. I can't even imagine that it was, and I can't even imagine what I was thinking. So anyway, that wasn't a good material to make the clapper out of. So what I did was I made another clapper. Yeah, not. And you can see that one. What I did was, and I can't compare the two too easily, but maybe you could see that clapper is a little thicker at the bottom. It's got a little smaller hole in it, and so I don't know how much good the hole does, but it does work quite well on the lathe, and I'll show you that. I'm not going to do a demonstration, but let's see here. Find that. I'll just give you a quick explanation here of a couple things. Let me zoom back out again. As you know, I made these spring tool holders for the lathe. This is a parting tool holder, and it's got the spring hole in it, and these are just made from 10/18 steel. That's it. But yesterday, I was I don't know, yesterday, day before, I was making these double nuts, and so in making these double nuts, what I had done is I turned a piece down and put the internal thread on it, and then stuck it in the 5C collet on the mill with the with the 90-degree collet housing, and I milled off the two sides. So now, then I put it back in the lathe to cut these nuts to length. And it was really interesting to sit and watch as I made the interrupted cut on the lathe at the spring action in this tool. It was amazing. It was doing just what it should do, and it worked just beautifully. So I use this tool almost every day, and this thing, I would never go back to the original. This thing just works wonderfully for parting, and I don't even have to think about it. It just works beautiful. The other thing that I might mention, that when in making this, let me zoom in a little bit there on that. In making this knob up here, I got to get out a ways here to show you, but this is the other tool holder I made for the forming tool. And right now, I don't know which radius. It has one of the radiuses in there that I use to cut the ball here on one of these or the other. I don't remember which one this is, but that thing worked also beautifully. I mean, I made the cut in a couple seconds, couple minutes, just slicker and whistle, and it was just incredible. So this thing, this tool holder was well worth it too. This was well worth the time and the effort I put into it, because and in grinding this little radius in here, actually you can either save it or you can regrind it. So if you grind the small radius, then you could regrind it bigger in a few seconds and make the bigger radius. So I don't remember what I did, whether I saved it and made new ones, but I just make them on the other end of the tool bits somewhere I got, and it just worked great. So those two things that I built were really beneficial, and I'm really happy about that. There's probably a whole bunch of other things I'm forgetting to tell you here, but those are some of the main things that and by the way, this clapper is working perfectly now. It doesn't seem to be any problem at all with it. I'm not worried about it breaking anymore or anything like that. Now, I'll probably braze this one back together again, but that's a few minute job, fairly easy to do. And maybe it's usable for something, I don't know, but it's cast iron, and I don't have much faith in it. It's brittle and it breaks easy. So that wasn't a good idea. The other thing is that I'm thinking, along with the vise is one thing that's on my mind. The other thing that's on my mind is the clapper itself. And I'm thinking, you know, that maybe I can make a clapper that holds a tool bit that sticks straight out from the clapper, and I can put a cutter on the end of this that would cut a be able to cut an internal keyway, or be able to cut square shoulders on a round hole. Now, I don't know if that's possible or not, but it's something I'm thinking about, and that may be a way to get a square hole in the base of the clapper for normal, what I'm calling normal tool bits. But these round tool bits work just fine. Don't get me wrong. It'd just be more convenient maybe to use a square one. So I don't know. You know, I guess it's just a preference. So anyway, Walter, I'm going to call off now, and this will probably be my last video for a while. So I just wanted to let you know where I was at, and I wanted to comment on your videos. I mean, what you're doing is just beautiful. It just looks absolutely marvelous. I love your eccentric idea, your locking cam. I think that's just going to be a dynamite setup. As you know, I milled out that section. I don't know if I can even see it on here. Probably can't see it. It's probably too dark. I'm trying to look at it, but I milled out this section down here for my nuts, and it's a lot of material to remove from a piece of steel. And it even on my mini lathe, and by the way, the mini lathe is not much different than your TEG lathe. I know you think it is, but the TEG looks like a tinker toy. The mini mill is a little bigger, but in reality, except for the Z-axis travel, my mini mill has exactly the same travel X and Y as your TEG does. Actually, my TEG has more travel than the mini mill because I've enlarged the Y-axis travel. So actually, I have more travel on my TEG mill than I have on the mini mill. So but it does give me the creaks to put this big block of steel on the table on the TEG mini mill, you know. And in fact, it bothers me a lot to put it on, I mean the TEG mill. And actually I should call it a micro mill, but it just gives me the creaks to put this on the mini mill too, you know, because it's 50 pounds or something, you know, and it weighs a lot. And normally if you're trying to, depending on how it's mounted, it's hanging way out. It's a lot of leverage against the table and the jib and all that. So it's not a good deal. So I agree, not the best deal in the world. Anyway, so I'll leave it at that and call off now and post this video, and then you know, like I say, it'll be a while before I make another video. So I just wanted to touch base with you. So have a good day. Talk to you later. Bye-bye.